Dear students, today's class we are going to talk about the transaction processing concept. Okay, so we are going to see about the transaction concept, transaction state, and the concurrent execution serializability. So these are all the things which we are going to see. Okay, what is a transaction? Transaction is nothing but basically it is an all or nothing. Either all has to be happen or nothing has to be happen. Okay, suppose if you go to the a bank, you are just paying the amount to get the DD. So you have to get the DD, then only the task is completed. Otherwise, they have to give back the money to you. Suppose, here, uh, transaction to transfer $50 from account A to account B. So we are reading A equal to A minus 50. Okay. So write A. Okay, so you can write the data. So and read B, you are reading the data, and this whatever we have minus we are adding here. So B is equal to B plus 50 and write B. Okay, so here you have in the transaction read write operations are there. Okay, so read can happen simultaneously. Read and write cannot be happen. Write and read also cannot be happen. Write and write also you cannot able to do it. Okay, so first here, so we are reading the A, and A is equal to A minus 50, the process done, and we are writing the A. Then we are reading the B, then we are adding the uh, 50 to B. Okay. So, in the transaction, there are two main issues are that sometimes the hardware fail. Sometimes if the server fail, we cannot access anything. We cannot, take money from the bank. Then concurrent execution. The system has to be very careful when we deal with the more than one concurrent execution. As I have told you, two people cannot able to write it, so that and all we have to be very careful. So now we are going to see about the ACID property. Okay, so this is one of the main concept in the database. So as I have already told you, transaction is nothing but it is an all or nothing. Okay, so in the ACID properties, A is nothing but atomicity, C is nothing but consistency. I is nothing but isolation and the durability. Okay. So atomicity is nothing but whether all has happened or nothing has happened. Okay. So that is a everything has to happen. Otherwise, we have to cancel all the things. Then consistency. Okay. So consistency of the database has to be maintained. If suppose I just paid the amount, tomorrow when I see if the system says you didn't pay the amount, okay, then I'll be in trouble. Okay, so the consistency has to be maintained. Then the isolation. Okay, so in the concurrent execution, which one has to execute first? If T1 is executing first, T2 has to execute second. Okay. So like that, the isolation. Who has to execute first? Okay. So that has to be clearly identified. Then durability. After its transaction completes successfully, even the system failures occurs, everything has to be corrected. Okay, so so that is what the durability. So in the ACID properties we have atomicity, that is all or nothing. Consistency. Okay, so preserve the consistency of the database. Isolation, which transaction has to do the first. Okay, so that things. Then the Durability, even if the failure occurs also, the system should have a clear things. Now we are going to talk about the transaction state. Okay. So there are different states are there in the transaction. One is the active state. Okay. So it is, that transaction state in this state while it is executing. Okay. The transaction is now alive. Okay. That is an active, partially committed. Okay. So so it is not, fully saved. Partial amount of execution has been, saved. Then failed is, the transaction can no longer proceed. It is a failure. Okay. Then the next one is, rollback. Okay. So rollback is nothing but, it is, if suppose, in the aborted transaction. Okay. So if it is aborted means, you can roll back the things. Okay. That is rollback. In the aborted one, either you can restart the transaction. One is something failure happen, you restart the transaction, or, you kill the transaction. The second one is, you kill the transaction. Then committed. So after successful completion, you are going to save that one. So you have, 5 transaction state. Active state, it is an alive one. Partially committed, it is a halfway, it is, saved. Failed is some transaction has been failed. Then aborted is nothing but, the things has been aborted. In how it will be aborted, you can restart the transaction or you can kill the transaction. Then committed, it's we are saving the information. So this is a transactions state diagram. So it's an active state can be, it can be a failure or it can be partially committed, or, after partially committed you can fully commit the things. You can fully save the one. In the failed one, either you can cancel that one or you can restart that one. That is an aborted state. Okay. So you can roll back the things. Something, if you wanted to correct the things, you can, you can undo the things. Okay, you can roll back the things. So, and as I have already told you, when you go with the read and write operations, you have to be very careful. So both person can read the data, but, both cannot write the data, and read and write is also not possible, and write and read is also not possible. This and all, you have to do the when you do the transaction, you have to be, you have to take care all these things. So concurrent execution. Why we are executing concurrently? Okay, simultaneously, why you are executing? And you wanted to increase the processor and disk utilization. We would like to increase the processor and disk utilization. That's why, we are going for the concurrent execution. And we would like to reduce the average response time. Okay. So we would like to reduce the average response time. That is why, we are just, executing concurrently. Okay. So the main thing is here, even though we execute the things concurrently, we would like to go with the isolation. So two process, when it is isolated only, you can go with the concurrent execution. If both is dependent on each other, in this case, maybe serializable way you can give. But if they depend on each other fully, it's very difficult to go with the concurrent execution. So you have to go with the isolated process, you have to go. So the next thing is, schedule. Okay. So schedule is which transaction is going to do it first, which you are going to do it second. Like that, you have to schedule it. Okay. This is what the commit and the abort. Okay, which one you have to commit it, or which one you have to abort. Okay, now, okay, so the what you are trying to give is here, you're just giving the serialization. Okay, so here you see A to B, $50 we are going to transfer. So that is a transaction one we have considered. So after the transaction one considered, we are committing that one. Okay, then we are transferring the 10% of the balance from A to B. So after the first transaction over only, the second transaction we are starting. In the second transaction, we are reading A, and we are just calculating the 10% you are calculating. Okay, and we are minusing from A. We are giving A minus temp, and you are writing the A. Now we are adding this temp value to B. Okay, after this we are committing. So here you see there are two things. $50 you are transferring from A to B, and 10% of the balance from A to B we are transferring. We are transferring. Okay. So once the transaction T1 is completed, only transaction T2 is completed. Okay, this is what serializability. Okay. Here, first T2 is completed. The schedule we have given is T2 is followed by T1. That is 10% is transferred from A to B. That is done in the first. We are committing that one. Then, $50 is transferred from A to B. So that we are doing in the second. Okay. So this is the way we are doing the schedule operation. Okay. So in this presentation, we have seen transaction. What is transaction? What is an asset properties, and what is a transaction state, concurrent execution, and the schedules. Right. So thank you all.